And for Algebra 2 class, and really this is just for Tom and Luke who are still both out. I hope you're feeling better, Tom, and your fever's gone. So let's go through this. Several of these problems are from the examples in the book as I'm showing in the margin. So problem 1 says, given the polynomial 4x to the third y plus 7x squared y to the third minus 15y to the fourth, find the degree of the polynomial. Well, this is consisting of three terms. The first term has a degree of x to the third y to the 1, or 3 plus 1 is 4. The middle term has a degree of 5, or x squared 2 plus 3 y third equals 5. And the last term has a degree of 4y to the fourth is 4. The degree of the polynomial is always the highest one, so that would be 5 for us here. And the number of terms is 3, giving us a trinomial. Now, 2 terms would be a binomial, and more than 3 would be a polynomial. Now, for problem 2, we want to evaluate the three expressions when x equals 2, y equals negative 3, and z equals 1/4. So plugging in the numbers for x squared plus y minus z, we would put in for x 2 squared plus minus 3 for y minus 1/4 for z, giving us 4 minus 3 minus 1/4, or 1 minus 1/4 is 3/4. For part B, we would plug in our x, y, and z for x squared minus y squared over xz, which would be 2 squared minus parentheses negative 3 squared over 2 times the fourth. 2 squared is 4, negative 3 squared is 9, so 4 minus 9 is negative 5, and then over 2 times 1/4 is a half. So negative 5 over a half is negative 5 times the reciprocal, or negative 5 times 2 is negative 10. For part C, we have parentheses 2x squared plus 3y cubed, and plugging in for x, we have 2 times 2 squared plus 3 times negative 3 for y, all cubed. So 2 times 2 squared is 2 times 4, 8, minus 9 cubed is negative 1 cubed, and as I'm showing, negative 1 times negative 1 times negative 1 is negative 1 for our answer. For problem 3, we have 5 minus absolute value of 2 minus 14 over 2 squared. So the absolute value of 2 minus 14 is the absolute value of negative 12, which is positive 12. So that gives us 5 minus 12 over 4 equals 5 minus 3, or 2. Now for 4, again, we're working with exponents. So we have 4x squared y, and I put the 1 above the y, times negative 3x to the minus 2y, the minus 4. Now when we multiply numbers and add the exponents. So we have negative 12, x to the 2 minus 2, y to the 1 minus 4, giving us negative 12x to the 0, y to the minus 3. Now x to the 0 is 1, and y to the minus 3 we put underneath the fraction bar to make it positive, giving us an answer of negative 12 over y to the third. Now, Tom, I remember you doing part B in class, r to the fourth, s to the 1, t to the seventh, over r to the minus 1, s to the 3, t to the 5. Now, when we divide exponents, we subtract. So we have r to the 4 minus negative 1, or 4 plus 1, s to the 1 minus 3, and t to the 7 minus 5, which gives us r to the 5th, s to the minus 2, t squared. Or putting the s minus 2 positive, r to the 5th, t squared over s squared. And now for 5, we're going to add 2 trinomials. The first one, 3x squared plus 2x minus 8, added to the second one, 5x squared minus 3x plus 9. Now I'm going to bring the second trinomial and put it underneath the first so that I can add the like terms. Now when I add exponents, I keep the exponent but just add the numbers. So 3 plus 5x squared is 8x squared. 2 minus 3 is negative 1x, or negative x, and negative 8 plus 9 is plus 1. So the answer there is 8x squared minus x plus 1. Now here on this next problem, I'm going to take 2a times the first trinomial 2a squared b plus ab minus 4b cubed, and then minus, and I'm putting a 1 there to remind us to multiply through, 5a cubed b plus 3ab squared minus 4ab cubed. Now above the parentheses term there, I'm putting what the multiply by negative 1 gives us, negative 5a third b minus 3ab squared minus a negative plus 4ab cubed. And multiplying the first trinomial by 2a, I get 4a cubed b plus 2a squared b minus 8ab cubed. And now taking the second trinomial and putting it under the first where the terms match up, I have 4a cubed b minus 5a cubed b is minus a cubed b, or just minus 1. Then the a squared b term is by itself, so it's plus 2a squared b. Now the negative 8ab cubed plus 4ab cubed gives me a negative 4 for that same term ab cubed. And then I bring along the negative 3a squared ab squared from the second trinomial. So the final answer is negative a cubed b plus 2a squared b minus 4ab cubed minus 3ab squared. Now in problem 6, I'm going to take 2x times parentheses x squared y to the third squared over parentheses 2x y minus 2 all to the negative 1. So that gives me 2, and I'm going to put a 1 power, x to the 1 power on top, x to the fourth, y to the sixth, over 2 to the minus 1, x to the minus 1, y2, y squared. Now taking the 2, I have 2 to the 1 minus 1, or 2 squared, x times x to the fourth, or x to the fifth, times y sixth, over x to the minus 1, y squared. And that 2 squared gives me 4, x to the fifth over x to the minus 1 is x to the sixth, and y fourth for an answer of 4x to the sixth, y to the fourth. Now for 7, what property is illustrated when I start with 2x minus 5 over 7 equals 3, and then come up with 2x minus 5 equals 21? Well, that's the multiplication property, or multiplying both sides by 7. Now for 8, I'm going to take 1/2 6x plus 3 minus 8x minus parentheses 3x minus 9 equals 13 halves. And to clear out the halves, I'll multiply all 4 things by 2. So multiplying the 2 times 1/2 on the 6x plus 3, I just get 6x plus 3, minus 2 times the 8x is minus 16x, and minus 2 times parentheses 3x minus 9 is minus 6x plus 18 equals 13. Now a 6x and a minus 6x cancel, so I've got negative 16x plus 21, 3 plus 18 equals 13, and subtracting 21 from both sides, I get negative 16 equals negative 8, and dividing by negative 16 on both sides, I simplify negative 8 over negative 16 to x equals 1/2. Now, problem 9 is coming from our word problem section 1.5, which we have examples in the book. So find 3 consecutive odd integers whose sum is 63. Now the first odd integer is n, the second odd integer is 2 more, because odd numbers are 2 apart, n plus 2, and the third odd integer is n plus 4 equals 63. Now adding up the n's, we have 3n, adding the 2 plus 4 is 6, equals 63. Subtracting 6 from both sides, we end up with 3n equals 57. Dividing both sides by 3, we end up with n equals 19. 2 more is 21, and 2 more is 23. So the 3 consecutive odd integers are 19, 21, and 23, and they do check. 9 plus 1 plus 3 is 13, carry the 1. 1 plus 1 plus 2 plus 2 is 6, 63. Now for 10, we want to find the perimeter if the polygon has a perimeter is 44. So we have sides or parts 3h plus 2, h plus 4, h plus 3 plus 5 plus 3 parentheses h plus 2. So when we add all the h's, we have a 3h plus an h plus an h plus a 3h is 8h. When we add the numbers, we have 2 plus 4 is 6, plus 3 plus 5 is 8, 6 plus 8 is 14, plus 6 is 20. So we have 8h plus 20 equals 44. Subtracting 20 from both sides, we have 8h equals 24. Dividing both sides by 8, we have h equals 3. For problem 11, we have another example of one of the word problems that's shown in the book for 1-5. So here we were given just one with different numbers, but the same exact problem. A total of $12,000 is invested in two funds. The first account yields 6% and the other account yields 8%. How much is invested in each of the accounts if the total interest earned is $800? Well, the 6% amount we're going to call X, and the 8% amount we're going to call what's left from the 12,000, or 12,000 minus X. So we start out with 0.06, 6% X, plus 0.08, parentheses 12,000 minus X equals 800. Now to clear out the decimals, we multiply everything by 100, which shifts the decimals 2 places to the right. So now we have 6x plus 8 times 12,000 minus x equals 80,000. And 6x plus 96,000 multiplying 8 times 12,000 minus 8x equals 80,000. And then 6x minus 8x is minus 2x plus 96,000 equals 80,000. Subtracting 96,000 gives us negative 2x is negative 16,000. Dividing by negative 2 gives us x equals 8,000 for the 6% amount. And the 12,000 minus x, what's left, is 4,000 for the 8% amount. Now the last problem for the quiz is solve for r if 1 over r equals 1 over r1 plus 1 over r2. Now we have to treat r1, r1, and r2 as though they were x, y, and z, 3 different letters. So the common denominator that I have to multiply by is r times r1 times r2. So doing that for all 3 parts, I have r times r1 times r2 times 1 over r, cancels the r's, equals r times r1 times r2 times 1 over r1, cancels the r1's, plus r times r1 times r2 times 1 over r2 cancels the r2's, leaving us with r1 r2 equals r times r2 plus r times r1. Now I've circled the common factor on the right side r, so I can take that out and say that r1 r2 is equal to r parentheses r2 plus r1, and to solve for r I can divide by parentheses r2 plus r1, giving me a final answer of r equals r1 r2 over r2 plus r1. So this is the quiz review, and I'll send this tonight, and I'll send the quiz tomorrow, and so just get those in as soon as you can, and thank you so much.